Hi everybody, this is Gigi from Kauai Community College. In this video, we will be combining power series. All right, let's get started. One of the power series that we know and that we love because it's pretty awesome is the geometric series, right? And the geometric series has the form 1 plus x squared plus x to the third, which is the series of x to the kth power. This series converges to 1 over 1 minus x for values of x that are less, the absolute value of x that is less than 1, right? So this is the condition. As long as x is in between -1 and 1, the geometric series will converge to 1 over 1 minus x. Now, since we know this, we could use it to express other functions in terms of a series. And this is how it's going to go, right? So we're going to start again with something like 1 over 1 minus x, which is of the form 1 plus x squared plus x to the third and so on, which we can write as the power series x to the k power. Now that happened when the absolute value of x is less than 1. Okay, so pay attention to that. The function that we have here is x to the fifth over 1 minus x. Well, you got the 1 minus x right. So to relate that to our geometric series, we are just going to have to multiply both sides by x to the fifth, which will give you x to the fifth plus x to the sixth and so on. So this can be written as the power series x to the k plus 5 power. Okay, now when does this series converge? Of course, when the part here is the absolute value of that is less than 1, meaning it is going to be the same radius of convergence as our geometric series, which is -1 to 1. All right, that's just straightforward multiply both sides by x to the fifth power. Now, suppose you have the function 1 over 1 minus 2x. Well, the geometric series is of the form 1 over 1 minus blank, right? Now that function can be expressed as a series, or we would say the series converges to that function when the blank, absolute value of blank is less than 1. Okay, so how do we relate that to that geometric series, our function f of x? Well, our function f of x has 1 minus 2x on the denominator. So the blank really is 2x, right? So wherever we see blank, we'll put in 2x. So then we would see this as our series, and we will write that as the series of 2x to the kth power. Now again, the series converges when the absolute value of blank is less than 1. And the blank we said is 2x. So in order for this series to converge, absolute value of 2x would have to be less than 1. Solving for that equation, we will see that the radius of convergence is 1/2, right? Or we would say that the interval of convergence is from -1/2 to +1/2. All right, that is just a substitution of 2x in for wherever the blank is. Now, suppose you were asked to find the power series representation for 1 over 1 plus x squared. Well, our geometric series said that if blank absolute value of blank is less than 1, it is going to converge to the function 1 over 1 minus blank. Well, how do we change that to look like that form, right? Again, don't forget, this only happens when the absolute value of blank is less than 1. All right, our function can be rewritten as, well, you're right. Plus is the same as minus a negative, right? So we can rewrite that as 1 minus a negative x squared. So then our blank is negative x squared. That is our blank, right? So when we substitute that in there, we will see that odd exponent is going to stay negative. Even exponent is going to turn negative into a positive. So we will observe that our series has an alternating nature to it, and the exponent will be just the even exponent. So we can write that as the series from 0 to infinity of negative 1 to the k power times x to the 2k. 2k will denote that that's just the even powers, right? And then the k right here, we need to make sure that we start with the correct sign, meaning we start with a positive. So when k is 0, negative 1 to the 0 power is positive 1. So that sign checks out. All right. So radius or interval of convergence is what we're going to go ahead and look at. Our blank needs to be, the absolute value of a blank needs to be less than 1. So absolute value of a negative x squared will be less than 1, meaning x squared is less than 1, and x is going to be in between negative 1 and 1. Okay? Let's take a look at one more. How does this work? This function has a 5 on the numerator, and then it has a plus sign. The 5 is like a multiple of 5, right? But let's go ahead and pause this video, start to doodle on your own, and see where you'll get. Once you're done, come back and see the solution. All right, so here we are. We will go ahead and start with the form 1 over 1 minus blank, and that is the geometric series of x to the k power when absolute value of blank is less than 1. So the function that we have, our f of x here, is going to be 5 times 1 minus a negative 3x squared. Okay, so our blank, as we observe, is there's gonna be a 5 in the front, right? That's the 5. And then our blank is going to be negative 3x squared. That is our blank right there. So do a little substitution in there, right? And then again, for the negative numbers, even exponent is going to turn that to a positive, and then odd exponent is going to stay negative. So again, we're going to have that alternating series there. And the 5 is still in the front, and I should close my bracket right there. Okay, and so we have 5 in the front alternating, so we know that we're going to have negative 1 to the k power. And then we will observe that the numbers here are 3 to the k power. And then the exponents here are just the even power, so it will be to the 2k. And that is our power series. Now, what is the interval of convergence for this particular power series? We say blank needs to be, the absolute value of blank is less than 1 for that to happen. So then negative 3x squared in absolute value must be less than 1. Solve that inequality, we will see that the interval of convergence is going to be in between negative square root of 3 over 3 and positive square root of 3 over 3. All right, so that is it for working with power series at this moment in terms of combining and doing a little substitution. Up next, we're going to be differentiating and integrating power series.